ever since even the 4th century BC and beyond, I imagine, there's been an interest in the possibility of life elsewhere. The Greek philosopher Metrodorus of Chios was very much interested and thought that it would be very foolish to think that with all the many possible worlds in the universe, that there would be only life on this planet. Lucretius, later on, 1st century BC, was of a similar opinion. And it was only with the rise of Ptolemaic understanding of the universe that people started to think of the universe as Earth-centered. And that was a later on phenomenon and not necessarily prevalent in early Greece. As a result, though, of Ptolemy's ideas in the Dark Ages in Western civilization, it was considered that Earth was the center of the universe and was the only place that life existed. Later on, that was overturned by the ideas of Copernicus and Kepler and those that followed.
Since the earliest of times, man has been interested in the heavens, having been fascinated by the countless points of light that sparkled in the darkness of the evening skies. One of these had a reddish hue to it and was known by several names depending on where one was. Many of the ancients named the planet we call Mars after their god of war, due to the planet's reddish hue, which reminded them of blood. In fact, the nickname the Red Planet comes from this, as does the notion that possible Martians would be warrior-like. Galileo's invention of the telescope in 1609, the first clear look at this, the 4th planet, became possible. Early astronomers believed that the Martian surface was similar to Earth's. The first telescopic drawings of Mars showing distinct changes in surface appearance were made by Christian Huygens in 1659. He observed that the Martian polar ice cap seemed to wax and wane, and dark patches seemed to appear on the surface of Mars. These observations led to the idea that Mars was indeed a habitable world, similar to our own Earth.
It was recognized as early as the 18th century that Mars was very much like the Earth. It had clouds, it had dark areas that people thought were seas. It had a time of day was very similar to the Earth. And so people imagined it to be like the Earth. And so they imagined that there was life there. And the prospect of really a life was, as I mentioned previously, reinforced by these observations of canals. However, as during earlier this century, it became clearer as we understood the conditions on Mars better that life, it was very difficult to have life on Mars, and the possibility of intelligent life was reduced to almost zero.
In 1877, an Italian astronomer, Giovanni V. Schiaparelli, observed lines on the Martian surface and called them canali. The English translation of canali is channels or grooves. These channels were mistakenly called canals in English, and the name stuck. Of course, canals would infer that some type of intelligent life form on Mars was capable of building these structures. In 1879, Schiaparelli reported seeing double lines of canali. He came to believe that these canali were rivers on the surface of Mars, a natural phenomenon. Others continued to think that the canali were artificial, that is to say, constructed by some life form.
Later on, Schiaparelli, the Italian astronomer, made observations of Mars, and in trying to make sense out of the visual image he saw of Mars on one of the closer oppositions, the word canali came into use because he thought he saw straight lines on the surface. This was seized upon by Percival Lowell, and he wrote a book in the 1890s that described the possibility of a Mars that would have intelligent life, water, but a dry planet in general, so the need to get the water down to the presumably more agriculturally inclined central parts of the planet. Percival Lowell maintained this interest in a living and civilized Mars until his death in 1916. And of course, his ideas were seized upon and made popular for a lot of us by Edgar Rice Burroughs, whose Barsoom series was fascinating and a lot of fun in a potboiler sort of way. And I got people's imaginations turned up about the ideas of civilizations on Mars, dying civilizations and recurrent civilizations. And I think that a lot of that stayed in the public mind. Certainly was something that I found of interest. Later on, we found that Mars was a much different place than Schiaparelli and Percival Lowell had imagined.
The American astronomer Percival Lowell was another who saw the canali and believed them to be artificially created. He made his observations with a variety of telescopes in different parts of the world. Starting in 1896, Lowell wrote the first of his 3 books about Mars.
There's been a long-standing interest with Mars and with life on Mars. And I think it traces back to the early telescope observations. When people finally started pointing telescopes at the planets, they noticed that Mars, unlike all the other planets, had distinct seasonal cycles, very similar to Earth. It had white polar caps, which shrank and grew with the seasons. It had dark spots on the surface, which seemed to come and go with the seasons, like vegetation. And it was this similarity between Earth and Mars, this superficial similarity, that I think was the spark that first started this interest in life on Mars and the notion that there was civilizations on Mars as well. And then I think all the subsequent observations, in some sense culminating with Percival Lowell's work looking for canals on Mars and the perception that there were canals, and that was an evidence of human civilization or human-like civilizations. All of that has tended to reinforce the notion that Mars was the planet that was the most like Earth.
Better information about Mars and its surface came with the development of new technology. The first breakthrough came in 1964 when NASA's Mariner 4 spacecraft flew by Mars at a distance of 9,844 kilometers. Mariner 4 returned 22 images of Mars, including some which showed impact craters on the surface and caused much comment among planetary scientists of the time. The images Mariner 4 returned gave us an image of Mars that was totally different than expected. It wasn't until late 1969, with Mariner 6 and 7, that we got a clearer look at the Martian surface. These 2 flybys gave scientists hundreds of images and showed many details of the surface that were once again totally unexpected. The imaging showed a planet stark and lunar-like in appearance, with craters and vast featureless areas. Also seen was chaotic terrain, unlike anything seen here on Earth or on the Moon. Craters ranging in size from 500 meters to 500 kilometers in diameter were seen.
After we started to fly by Mars with spacecraft, we found that Mars was a much drier place than it ever had been conceived of before, and also one where a very low atmospheric pressure, less than 1% of that of the Earth. Total surface area of Mars is approximately that of the Earth dry land surface, so it's a fairly large planet in terms of possibilities. And as a separate world, anything you say about any particular place on Mars may not pertain everywhere on Mars.
A 4th Mariner mission, Mariner 9, was successfully launched on May 30th, 1971. The spacecraft was inserted into Mars orbit in November of 1971 and functioned for 349 days, returning almost 7,000 images. When Mariner 9 first reached Mars, an intense dust storm had obscured most of the Martian surface, so scientists used the opportunity to study the Martian moons, Deimos and Phobos. Mariner 9 eventually mapped over 85% of the Martian surface, with images having a resolution of approximately 1 kilometer. Imaging returned from this mission gave scientists the first really comprehensive look at the red planet. Other experiments on board Mariner 9 told scientists that Mars was a very cold planet and that the Martian atmosphere was about 1% as dense as the Earth's atmosphere at sea level.
The real dramatic change came in 1971 when an orbiter was put around Mars and began to systematically look at the entire planet. And it just revealed a fascinating place with huge volcanoes, vast canyons, enormous dry riverbeds, sand dunes, just an incredibly variable planet. And particularly fascinating were all these indications that water had flowed across the surface. And some of the features were really quite startling because there were large dry riverbeds that were suggestive of large floods. And these floods were in enormous magnitude. They would have had discharges 100 times the discharge of the present Mississippi. Of course, it just lasted a short time. But as a consequence, people began to rethink about what Mars, how Mars might have formed and what conditions were like in the past.
Many other features on Mars were seen for the first time. In addition to Olympus Mons, one of the largest known volcanoes in the solar system, there were vast valleys on the surface of Mars, as well as canyons, one of which is much longer and deeper than the Grand Canyon in the United States. This Martian abyss, Valles Marineris, extends over 2,000 kilometers. Other formations and deposits seem to indicate that long ago in Martian history, there were large amounts of water present on the surface of Mars. Mars was still an enigma to scientists and researchers after Mariner 9. They wanted and needed to know much more about Mars, specifically whether or not there was or had been life there. So another unmanned mission to Mars was in the works, Viking. Vikings 1 and 2 were launched from Cape Kennedy in the summer of 1975 and reached Mars in the summer of 1976. The primary objectives of these spacecraft were to safely land on the surface of Mars and to attempt to determine if there was some type of life on Mars, either now or in the past. The Mariner missions did not tell scientists if there was life on Mars, and in the end, Viking did not conclusively answer this question either. The Viking spacecraft each consisted of 2 separate spacecraft. There was an instrumented orbiter section which remained in orbit above Mars, taking readings and measurements, taking pictures, and acting as a relay satellite for the Viking landers. These landers were miniature laboratories.
The goal of the Viking project was the exploration of Mars. And we had had missions that went to Mars before, but the goal of the Viking was to land spacecraft on the surface and actually explore in situ what Mars was like. It was like being on Mars. We actually had experiments that one would do if one of us were lucky enough to be landed on the planet and dug up handfuls of Mars and had a little laboratory there. It was fundamentally what Viking was all about. We used 2 spacecraft to do that. We had a spacecraft that was a lander and a spacecraft that was an orbiter. It was kind of like a mother and a daughter. The mother was the one that received the information and did a little investigation on its own, and the lander was primarily used to do the kinds of things that if we were having a field trip on Mars, we would have sent an exploration party out to Mars to do that kind of experiment. They involved meteorology, they involved biology, they involved chemistry, they involved geology. Of course, the biology was a predominant question that we had because that was the kind of the bell ringer. But nevertheless, the whole point of the Viking was to explore in breadth what Mars was like and how similar or how different it is from the Earth. The Viking spacecraft consisted of 2 parts. An orbiter that was placed into orbit around Mars that carried the daughter ship that was then allowed to descend to the surface of the planet. The orbiter consisted of a large spacecraft with very large solar panels so that it could absorb the sun's energy, convert it into electrical power, and be run. The orbiter was placed into an elliptical orbit around Mars. The periapsis of the planet was about 1,500 kilometers. The apapsis of the orbit was put in about 30,000 kilometers. Imagine this orbiter now passing over a landing site with a distance of about 1,500 kilometers, trying to take pictures of a landing site that was later going to be used for the daughter ship. The lander, which was folded up like a chrysalis of a butterfly, would be later landed by descending to the surface. The descent to the surface was tricky because the Mars atmosphere was just thin enough to burn you up and not thick enough to slow you down. And so there was this unique problem of a landing system that wasn't just a parachute. In fact, we had 3 braking systems on Mars. Once down into the Mars atmosphere, a parachute was popped. Now, this was no ordinary parachute. This was a parachute that had to slow the spacecraft down at about Mach 4. The parachute got us down to within about 100 kilometers, and then a retro rocket system was used. The retro rockets were firing their rockets down against the Mars surface to slowly slow the spacecraft down, in combination with a radar that would tell us how far we were from the surface and allow this spacecraft to descend to the surface. The very last moments would be like jumping off a small table so that you'd settle down onto the Mars atmosphere and protect those valuable scientific instruments from a crash.
The first lander was originally scheduled to set down on the surface on July 4th, 1976, in honor of America's bicentennial. However, when the spacecraft reached Mars and began imaging the proposed landing sites, the scientists saw a younger and more dynamic planet than they had expected. After 2 weeks of studying the images returned from Mars, a new landing site was selected, and the Viking 1 lander set down on the Chryse Planitia on July 20th, 1976. The Viking 2 lander safely soft landed on the Utopia Planitia on September 3rd, 1976. The selection of the landing sites was one of the more controversial issues of the Viking missions. The biologists wanted an area that would be the most hospitable to life, and the landing team wanted a site most conducive to a safe landing.
As soon as the lander was down onto the surface, there were two things done. One, the well-being of the spacecraft. Think about you're trying to land some kind of an instrument anywheres. First thing to do is to make sure that the system is working, elevates the antenna to talk back to the Earth, takes temperature measurements to make sure that the spacecraft is all right, a kind of housekeeping maneuver. Then the most important piece of scientific data to come back would be the first picture. And the very first picture pointed down to the footpad to make sure that the instruments were stable, that the spacecraft was stable, and also to see what the Martian surface was like. I will never forget that first evening when we first saw the first pictures coming back, bit by bit, line by line, sweeping across the Mars surface and seeing for the first time that it was a surface that was familiar in the sense that it looked a little bit like some pictures we've seen of the Earth, that it wasn't like the Moon at all. There were rocks in the surface, there were features to the surface. We didn't get a horizon until the second picture. The first picture was just to say, it's sort of like looking down at your own foot if you stepped onto a brand new planet and said, what is it like on this planet?
In time, the other experiments were successfully activated, and the results were anxiously awaited here on Earth. Scientists were elated at this, the first opportunity to look for life on another planet in situ. But data from the experiments on the surface of Mars was inconclusive. Additionally, the meteorology packages showed Mars to have an extremely cold and hostile environment to life as we know it here on Earth. The 3 biology experiments were designed to detect activity of microorganisms, as we understand them, if there were any present in the Martian soil that Viking gathered for testing. These experiment packages measured a gas exchange with the surface sample for both the incorporation and release of radioactive carbon-14. In one experiment, immediately after heating and humidifying a soil sample with a complex nutrient, oxygen was detected. About 15 times as much oxygen as is known to be present in the Martian atmosphere was released. This result is now thought to have been caused by a chemical reaction between the soil sample and the nutrient solution, as opposed to an indication of life. But at the time, and until all the data returned had a chance to be reviewed, analyzed, and reanalyzed, no one could say for certain what this reaction meant.
In a third experiment that we kind of laughingly called the chicken soup experiment, we actually tried to grow some organisms. We took a mixture of delicious terrestrial ingredients, all sorts of vitamins and minerals and extracts and amino acids and sugars and all the goodies that you would use if you were going to grow up some organisms. And the idea was to inoculate the sample with these goodies. Now, in the experiment, we had a novel first stage before we actually inoculated the sample. we wanted to humidify it. Some terrestrial organisms that form spores are known to die as a result of the ingestion of water. So the idea is to do what we do with spore formers on the Earth. We first humidify, just expose it to water, and then finally grow up the organisms. In the case of that experiment, we had a great surprise. Instead of the first humidification having no result, which was what we would see here on Earth, we saw enormous quantities of oxygen that came out of the sample. For reasons that at the time were very confusing to us, we saw this release of oxygen, not at all what you'd find here on the Earth. Finally, after some thought, we figured out what that oxygen was. We finally figured out that Mars, the surface of Mars, has some peroxides, as though there were kind of bleach or something spilled on the surface. These were a little like hydrogen peroxide, although there's no hydrogen peroxide on Mars. It's probably iron peroxide. A peroxide is something that is known to give up oxygen, and when you add water to a peroxide, this oxygen is released. A kind of self-sterilizing surface in a way. We don't know that that's the fact on Mars, but that's a possibility. And in fact, it explains what happened in the second experiment. In the second experiment, where we had added the growth media, probably what happened is the peroxide on Mars reacted with the growth media and released some of the carbon dioxide as though it were being broken down by organisms, a kind of chemical reaction. So in fact, the two experiments blended together so that the results of the third gas exchange experiment told us something about the answer to the second, the labeled release experiment.
Some of the people who have been interested then on life on Mars participated in the Viking mission in 1975 launch, 1976 landing, where they sifted the very fine surface material and put it into what was called the Viking biology package and conducted a series of experiments looking for life on Mars. The results of those experiments were equivocal. There were some reactions in the experiments that were consistent with life, some that were inconsistent with life. And generally, the tie vote got ascribed to a device called a gas chromatography mass spectroscopy device, the GCMS. And the GCMS showed no evidence for organic material in the soil. It wasn't able to get, final evidence that none existed on Mars, and it was only looking at material taken from about the first 4 inches of the surface. But because there was no organic material detectable by the GCMS, it was thought that the reactions that were seen in the Viking biology package were inconsistent with life as we know it.
At present, most scientists and researchers discount the theory that intelligent life was ever present on Mars. There are those, however, who believe that at some time in Martian history, there was intelligent life on the planet. This minority claims that features seen in certain images returned by the Viking orbiters of the Martian surface show signs of past intelligent life there. They feel that some of the features seen in certain images are actually monuments left behind by a past Martian-based civilization for us to find and use as a beacon to home in on, to find the remnants of this proposed civilization. Although not endorsed by NASA, Richard Hoagland, space author and lecturer, feels that some of the Viking images suggest a past intelligent civilization on Mars.
A set of photographs taken on the morning of July 25th, 1976, came in through the various channels back to the computers at JPL, and then to those of us who were gathered at JPL to witness this historic first landing of a spacecraft on another planet. And one of those photographs showed a mile-long, 1,500-foot-high mesa in the Cydonia region, the northern deserts, that was literally out of place. It did not belong. It cried out for explanation, if only for reassurance that it could not be real, because the object looked like a humanoid face.
It's highly speculative. There's no question about it that there's an interesting feature on Mars that appears to look like a human face. I think that this speculation is all very much interesting to sell newspapers, but there's not a lot of scientific credibility in it. Unfortunately, we don't have enough data to address the question of why this happens to look like a human face, but I would suggest that one of the most adaptive features that humans have is the ability to recognize human faces.
In order to envision that those monuments were created by a civilization, an intelligent civilization, you really need to extrapolate our knowledge of evolution and biological processes enormously. Somehow you have to envision that life started on Mars and it evolved very rapidly and persisted even in the face of adverse conditions. As the planet got colder and drier, it would have been difficult for life to have continued. And somehow, to imagine a civilization there would have required that it did so. The evidence of the monuments and the faces is very interesting. I think they are interesting geological features.
Some of the people who claim that the monuments on Mars and the face on Mars are indeed artifacts from an extinct civilization do not claim that intelligent life or the life forms that may have constructed these alleged structures evolved on Mars. Rather, they say that the beings may have come from another planet, another solar system, or another galaxy. The idea that this supposed complex of structures on Mars are a construct stems from their geometric alignment.
We have found other provocative sets of objects, and the important thing is sets, because at the resolution we're looking at, 50 meters, 100 meters, you're not going to see structures of comparable size to those on Earth. You're seeing much larger objects, and the only indicator that they are made by intelligence is their relative geometric placement relative to other objects. Carl Sagan, who has some credentials for pronouncements in this area, has said that on Earth, the first indicator of intelligent design is the geometric regularity of our constructions. Taking that rule of thumb and applying it to another planet like Mars, if we see a set of objects in a very particular geometric configuration, the suspicion is raised, just the suspicion, that maybe we should look closer. Unfortunately, we only have really good coverage in Cydonia. We do not have dual sets of pictures taken at two different sun angles like we do at Cydonia in other places.
Both sides do agree on 2 points. First, the face is indeed a very fascinating image, but what it is or means is still open for speculation. And second, that the Mars Observer spacecraft should definitely be used to return higher resolution images and more complete imaging than anything Viking sent back. The ultimate answer to the question of were these features made by some life form or caused by natural processes on the Martian surface awaits us. But until a human sets foot on the surface of Mars and can examine the evidence firsthand, we will have to continue to be satisfied with robotic exploration.
I guess you're about the only person around that doesn't have TV coverage of the scene.
That's all right, I don't mind a bit.
They've got the flag up now, and you can see the stars and stripes on the lunar
Flag up
surface.
now, you can see the stars and stripes.
Are you getting a TV picture now, Houston? Neil, yes, we are getting a TV picture. You're in our field of view now.
That's one small step for man, one giant leap